In this example, we will be analyzing specific types of exponential functions. So for example, on the first one, suppose that the dollar value of a certain car that is t years old is given by the following exponential function. V of t equals 25,900, and then in parentheses 0.91 to the power t. So our general exponential equation that we're working with looks like this. P equals P naught b to the power t, where p naught is the initial value. So the initial value for any word problem like this will just be a number outside of the parentheses, so before you put something to the power. So part A says find the initial value of the car. That is just going to be the number in front of the parenthesis. So since value is done in money, $ for the units, and then 25,900. No calculations needed. This is just something that you need to recognize. Does this function represent the growth or decay? That is determined by the b value. So this value inside the parentheses, that's what determines whether it's growth or decay. Growth means that b is bigger than 1. For us, that's not true. Decay means that b is less than 1. That is our problem number 1. Our b is 0.91. That is less than 1, so this indicates a decay. By what percent does the value of the car change each year? This question actually needs some calculations. So by definition, for the decay function, b is 1 minus r. We need to get r out of that equation. So rearrange to get just r. R equals 1 minus b. So now I can plug that in. R equals 1 minus my b is 0.91. Do the calculations, 0.09. But then r is a rate, and it's always measured in percent. So we need to multiply this 0.09 by 100 to get percent. So this is 9%. We did that by multiplying by 100. So that is the answer to part C. So let's try that again. A study is done on the number of bacteria cells in the petri dish. Suppose that the population size P of t after t hours is given by the following exponential function. 2300 times 1.05 to the power t. So our generic equation is still the same. P equals P naught b to the power t, where p naught is the initial population size. P naught for us is 2300, so that is what we're going to put here. Since it is bacteria, the units is bacteria. Does the function represent growth or decay? So our b, this is p naught, b is 1.05. which is bigger than 1, so this is a growth problem. By what percent does the population size change each hour? Well, for the growth problem, b is 1 plus r. Again, rearrange for r. R would be b minus 1. So that's 1.05 minus 1. That's 0.05. And again, since we need percent, we need to multiply that by 100. So that is 5%.